All right, cuties. I thought maybe some of you could use a little tutorial on how to solve some of these molar conversion problems, and I thought you might like to see me solving them. I'm working on my Chromebook. I'm going to fold it over, so you'll be looking at my ceiling. Sorry about that, but I feel like that's the best way for me to work here. All right, so actually I have to erase this one little weird line that I accidentally drew on here. There we go. Make that go away. We'll pick a fun color to work with first. Let's start with, I don't know, pink. Okay, how many molecules are there in 24 grams? So we're actually starting off right off the bat with a grams to molecules equation, and that's one of the hardest ones. That's a two-step equation. So what I always do is I write down what they give me first. So they gave me 24 grams of, and I never stop writing. I never skip a step. So they gave me 24 grams of FeF3. And then I'm going to have to do two conversions to go all the way from grams to molecules. And then what I always try to do is write out the unit that I'm looking for. So I'm looking for molecules of FeF3. That's what I'm looking for, is molecules of that. So now I need to do two conversions. If I was using the mole roadmap, you can look at that. You're going to go from grams to moles, and then you're going to go from moles to particles or molecules. So the first thing I want to do is put grams of FeF3 on the bottom and 1 mole on the top. Remember that I'm trying to cancel out my units. So notice if I put grams on the top, I can put grams on the bottom and they cancel out. But the question is, KJ, how many grams? Well, that's what we get from adding up everything that's on the periodic table. So I'm going to add up Fe, and I'm going to do that on my calculator as fast as I can. So iron is 55.847. Oh, and now my calculator's not working. 55.847 plus parentheses. F is 18.998. 18.998 times 3 close parentheses equal. So my molar mass is 112.841. 112.841. I think we told you could go to 2 decimals, and that's totally fine. You could do that. So now I've canceled out my grams. Those are gone, but I'm left with moles. I'm looking for molecules. So that means I still have one more step to go. So to get my moles to cancel on the top, I'm going to put moles on the bottom. And when you're doing a conversion factor, it's always 1 mole. So 1 mole on the bottom. And on the top, I want to put my Avogadro's number, 6.022 times 10 to the 23rd molecules. And you are welcome to ask me why I didn't give myself more space, because that was poor planning on my part. All right, so now my moles cancel out, and the only unit that I'm left with is molecules, and that was the answer I was looking for. So now I'm going to switch colors here really quickly so you can see what I'm doing. I'm going to do 24 times 1 times 6.02 times 10 to the 23rd. And then I'm going to put in parentheses, I'm going to divide by, and parentheses, 112.841 times 1. Now, that was all 1, so it's not a big deal. But if I enter it into my calculator, 24 times 6.022 times 10 to the 23rd. Where is that on my calculator? There we go. 23rd equals, and then I'm going to divide by 112.841, and I get 1.28 times 10 to the 23rd molecules. Now, is that a number that makes sense? When I'm talking about molecules, would I have a huge number? And the answer is yeah, for sure. If I was talking grams or moles, that number is way too big. That's a crazy number. But as far as talking about molecules, that's a sensible number. All right, let's try another one. How many molecules are there in 450 grams? So this is another two-step problem. So I'm going to write down, I'm going to see if I can write it a little bit smaller this time. So we'll write 450 grams of, what did we have? Na2SO4 times, I'm going to make a conversion factor, times another conversion factor equals, and I'm going to write down what I'm looking for. Apparently, I'm looking for molecules. So I'm going to write that all the way over here. I'm looking for molecules of Na2SO4. So let's see what we need to do. The first thing I notice is that my units is in grams, so I know I'm going to want grams of Na2SO4 here so they cancel out. And so this is going to be on my mole roadmap. I would be going from grams to moles. So I would put 1 mole on the top, 1 mole. You can write E on the end if you want it. And now I have to add up Na2SO4, and that's always the part that's time consuming. So 22.99 times 2 for 2. So I've got 2 sodiums plus a sulfur. It looks like sulfur is 32.064 plus, and then I had 4 oxygens, 4 times, I'm just going to say 16.00, close parentheses equals. It's hard for me to do this math while I'm talking, so hopefully I'm doing it right, but you get the idea at least, 142.044. And so now I want you to notice that my units have canceled out. I have grams over grams, so that unit canceled out. Now I want my moles to cancel out. I'm left with moles, so I want that to cancel out. So I'm going to put 1 mole on the bottom, and now those 2 units are going to cancel out. And on my mole roadmap, I'm going from the center up to the molecules, and this is where I put in 6.022 times 10 to the 23rd. That's a 2. Molecules. Don't abbreviate molecules so you don't get it mixed up with moles. Again, I am noticing that my mole unit has canceled out and I'm left with the unit molecules, which is the unit that I was in fact looking for. So it should be a very big number since we're talking about molecules. So I'm going to go ahead and multiply it all out. 450 times 6.022 times 10 to the 23rd equals, divided by 142.044 times 1, we don't have to worry about that, equals, and I got 1.907, so I'm going to round that to 1.91 times 10 to the 24th molecules. So shrink that up. It looks a little stupid, but there it is. That would be my answer for the next one. All right, let's see if we can find one that's a little bit different. We're going from grams to atoms on this one. So this is a 2-step one also. I'm wondering if there's any others that are not 2 steps. Are these all 2 steps? Well, I was thinking there were others that were not 2 steps, but it looks like these are all 2-step problems. Molecules to grams, grams to molecules. Yeah, these are all just 2-step problems. I thought there were going to be a few 1-step problems, but these are all the double 2-step problems. So I'll skip around. Let's try another one here. How many grams are there in? All right, so let's try that. So how many grams are there? I'm going to try problem number 5. They give us this number here, so that's what I'm going to write down first. So I'm going to blow it up big so I can see it better. So 7.5 times 10 to the 23rd molecules. And again, I don't get lazy with writing my labels because it makes a huge difference, especially later on in this course. You're going to be so grateful if you are used to writing everything out and not skipping. All right, so I want to get rid of molecules. So that means I'm going to put molecules on the bottom of H2SO4. And this is my conversion factor. So in 1 mole, there are 6.022 times 10 to the 23rd molecules of H2SO4. Now notice that my molecules of H2SO4 have canceled out. And right now I have the unit of moles. So now I'm going to put 1 mole on the bottom to make that cancel out. And the unit, I never finished this, I'm sorry, the unit that I'm looking for is grams of H2SO4. So I want to put grams of H2SO4 on the top. That way my moles cancel out. I'll show you my moles canceling out. And I'm left with the unit that I'm looking for, which is this one right here. So now I need to figure out how many grams are there in 1 mole of H2SO4? That's where I go to my periodic table, and I'm trying to show it to my camera. There we go. Go to the periodic table. 2 H's is 2 times 1.008 plus a sulfur is 32.064. Hope I did that right. Plus 4 oxygens, 4 times, I'm just going to round to 16 here, equals 98.08. And when I multiply it all out, let me pinch it in so we can see it a little bit better. So 98.08 times 1 right here times this number here, 7.5 times 10 to the 23rd equals, and then I'm going to divide that by this big, huge number. I'm going to put that in parentheses. 6.022 times 10 y to the x 23 close parentheses and equals, and I should get a small number, small meaning it's not times 10 to the 23rd. So the answer that I get is 122. I'm not going to worry about the sig figs right now because we did tell you could go to 2 decimal places, and I've been going to 3 sometimes, so I'm not worried about that. I'm just trying to show you how to do the calculations. So I feel like you got the hang of the calculations. Maybe we can do one more just to make sure you feel confident about it. Let's try. I don't even know what would be any different than the ones we just did. We've done molecules to grams, and we've done 2 molecules to. We did 2 grams to molecules. We've done 1 molecules to grams. So let's try one more molecules to grams. Let's try number 8. So what they give us is, I'm going to make it bigger here. What they give us is 230 grams of COCl2. And now I'm going to have to do 2 conversion factors. I'm going to make that one longer. 2 conversion factors. If you look at the mole roadmap, you have to take 2 steps in order to get there. And what I'm looking for is molecules, and that should be a really big number. Oops, I can't get it to scoot over. Sorry, my Chromebook is freezing. Okay, so molecules. I didn't do the one that I meant to do. Oh, well, that's okay. Molecules of CO. Oh, my goodness. C little o, not capital O, because that would be carbon dioxide, carbon monoxide, Cl2. All right, so it should be a really big number if I've done it correctly. So we've got 200. How did that erase? What did I screw up? 230 grams. So I know I'm going to want grams of COCl2 on the bottom, and I'm going to want 1 mole. This is my conversion factor. So how many grams of cobalt chloride? So let's find cobalt. I have no idea where that is on my periodic table. It's going to take me about half an hour to find it, isn't it? Oh, goodness. There it is. Okay, so cobalt is 58.993. 58.993 plus we need 2 chlorines, so parentheses 35.453 times 2 close parentheses equals, looks like the mass, the molar mass is 129. There's several different ways to round this off, so I'm just going to say 129.9 for the moment. I'm not following sig figs. I'm being very naughty. So that made my grams of cobalt chloride go away. I'm left with moles, so moles needs to go on the bottom. That way they will cancel out. And what I'm looking for is molecules. And so I want the top to be molecules of that COCl2. And the molecules in 1 mole is always 6.02 times 10 to the 23rd. All right, so now we multiply it all together. So 230 times 1, we don't need to worry about that, times 6.02 times 10 to the 23rd equals, divided by, and then I'm just going to do 129.9 equals, and I get approximately, again, I was not doing good sig figs here, you guys. You need to do good sig figs. 1.0 7, it'll round off to, times 10 to the 24th molecules. It's an enormous number. Does that make sense when I'm doing molecules? Sure does. All right, hopefully that was helpful to just kind of get to see how I how I do these conversions. Let me know if you have questions. Thanks. See if I can get this thing to stop now.